Hello, everyone. Welcome, welcome to my talk. I know it's hard, just right after lunch, so I will skip the boilerplate, like what is LLM and what is AI and what can we do with it. And in this talk, I will focus on new models on O3 and O4-mini from OpenAI. And I will talk about the experience that we gained from using it in production, and mainly was the difference between using reasoning models and agents. So at first I'm going to introduce myself and what we do. Then I will focus on agentic approach. I will show you some LangGraph code. Unfortunately, it's in Python. Then I will switch to reasoning models. And then we're going to tackle some real-world use cases for both agentic use and the reasoning models. Oh, but this it keeps switching off. Okay, and then I will take questions. So, who am I? My name is Tomas Rehak. I do the CTO position at agrp.dev, and we're a Czech company, and we're a leading software company in terms of legal tech. So we do codexes, which is our main product, and we have some other business-to-business software as well. And as you can imagine, a legal domain and LLMs, it's very, it just like goes hand in hand because it's all words, you know. You go to a lawyer, you ask a question, and he's like, okay, 1,000 euros, yeah. So maybe I can just ask ChatGPT. Depends. Sometimes it works, sometimes it doesn't. And we've been playing extensively with LLMs since GPT 3.5 came out. And I'd like to thank you. Thank you as the audience, and thank you to the organizers for hosting this great conference. It's always a pleasure to be here. So, how many of you does use agents in production? One, okay, not sure. And how many of you did implement any like agentic code, maybe just for fun? Somebody else? Two, okay, two. So, what's your experience with agents in production? Is it okay or?
A lot of fine-tuning.
A lot of fine-tuning. A lot of manual things, yeah. But it's actually very, it looks simple. You just define the application flow, the control flow. Like, for example, first identify the user. Then if it has like a billing problems, put him to the billing agent. Then if it has some subscription problems, put him to the subscription agent. This like divide strategy, it should be working now. But in reality, it's quite convoluted, and it's impossible to cover all use cases. Always there will be a use case which we didn't think of when designing agents. So the agents will get to some like dead end, or worse, they will cycle. You know, just keep looking for a good agent to hand off the work. We'll see. Maybe we can replicate this during the demo. So when I was working on this talk, at first I was using LangChain and LangGraph, and then I saw the presentation on ADK, the new Google framework for agents. I think it was yesterday, and I switched to ADK and rewrote the demo to ADK yesterday. So we'll see if it works. Basically, all these frameworks, these tools, are here to simplify the operations with agents, to let you model state transitions, conditions, memory, tools, whatever you think the agents might use. So the key idea here is that the agents should support some like very complex workflow. It's not just a simple request response, but there are some like actions and intermediate states. So it like will walk the customer or the user through all the process. So it's based on like divide and conquer idea and idea of specialization, because like in my opinion the agents are trying to mimic the human society. Like for example, if you have an accounting problem, you usually don't solve it yourself because your knowledge about accounting is limited. If you want to say build a new house, yeah, sure, you can do it yourself, but usually maybe for electricity or something, you go to a specialized agent called the electrician or the plumber. You don't do the stuff yourself. Why is it so? I think mainly it's because of the context limitation, because the context size is limited, as we know. So I think at first the agents were designed to, say, make a workaround around this context limitation. So if one agent is used only for a fraction of task, he has enough context to complete this fraction of the whole task. But there's not enough context or not enough tools in a single agent to all the operations. You'd run out of context. And each agent can be, as you said, fine-tuned or manually optimized for the task. So you can play with prompts, you can play with tools, you can benchmark it. Does anybody of you benchmark your LLM things in production? Like, do you have any like automated, only you? Do you have any like automated benchmarks? You know, like what happens if you change your system prompt, or if you change the model, or if the new model version comes out, how it affects your performance. I think it's a critical step, and it's very underhyped, I think. So these agents and agent frameworks, they usually look like this. There's an agent, he has a memory, he can do some planning, you know, like for example, if you ask this like electrician agent, I need the new electricity in my house, I need new wires and stuff. First it has to like make a map of the house, then it has to like make a plan of where it's gonna dig, what wires to buy, and then maybe delegate the procurement process to the procurement agent. It has some tools to actually like do the work, and it can take actions. Then there are some like techniques. It's called act or react. It's like a reflection and self-critics. So you just take the prompt, send it to LLM, then apply a critique on the result, send it to LLM again. So it's a lot of like manual steps and manual workarounds on fine-tuning the results, because usually you're not happy with the first thing that like comes off your fingers. And these tools, it can be anything, like you can access the calendar, for example, just to know the current date, because it's a problem. There's no like date in the LLMs by itself. Access the code interpreter. So if you need to make calculations, it's always good to have like Python handy. Do some web search, maybe fetch some web pages. It's very use case specific. And we have all these like shiny graphs. See a lot of nodes and a lot of edges and conditions. In theory, it's very simple. It's just like, for example, this Rehak retrieval. You retrieve it and you grade it, Is it relevant? No. So you retrieve some more stuff. Is it relevant? No. Okay, so I make another like search. Is it relevant? No. You know, see, I can get in a cycle very easily. And if I'm lucky and I'm gonna find something relevant, and yes, finally I have like relevant pieces of information, and I can answer. There's a lot of limitations. Like for example, on this slide we saw that we gave LLM like 5 tools, 6 tools, and if the number of tools goes into dozens or maybe like 100, the LLM will start to hallucinate. It will stop, like make proper tool calls. It's just like too much information. It's a choice paralysis. It has no idea what to do. And then, like as we saw in some demos here in GeeCON, it delegates to human in the loop and ask questions like, "What should I do now? Where's the information?" So you actually have to like push it, which is not, in my opinion, which is not an agent, because if you have to like steer it and push it and give it advice, then most of the time it's actually like, easier to do it yourself. So here's an illustration of another fancy graph. So the real world use case. There are some, sure, but what does it mean? Why so few? Well, it's because the failure, and it's because of cascading failures after n steps, multiple steps. The context isolation, tool isolation leads to like the global knowledge isolation and separation, which leads to failures. So Salesforce did some research, and these are the actual numbers from the research. They tried to implement the ACT architecture, the React architecture, and some like function calling. And this is the success rate. So if you're looking for consistency, you can see it's consistently failing, because the success rate is, the best success rate is about like 40%, which is not like good enough. You wouldn't keep an employee who would make errors in like 6 out of 10 times. So these things are worse, and the ACT and React architecture is even worse. And there's a story about Klarna. Does anybody know it? Anybody heard it? Yeah. For the rest of you, the Klarna, they implemented, they replaced, I think 700 human customer support agents with agents, like AI agents, and now they are replacing it back with humans, because it was a total disaster, it was a total failure. The customer satisfaction dropped, the agents didn't know what to do, it didn't behave well, it kept like hallucinating, and the overall satisfaction with this solution was very low. So it does not, maybe yet, scale very well outside of defined and very narrow domain, which is usually not something that like we want to do, because if we have a narrow domain, we can use just standard UI. We don't need AI agents. It's hard to expand, because if you add something, then you have to retest the whole system and see if something changed. So the question, as it stands, is if we can do any better than this. I think yes, just only recently. OpenAI introduced in September the research preview and general availability in December 24 of OpenAI O1, which is reinforcement language model. It would be nice if we had any benchmarks, like for example, okay, so we have this like 4.0 and 0.4 and 4.5 and 4.1 and 4.5. which is actually dumber than O3, which is dumber than O1 Pro. So there's a bit of confusion. So are there any benchmarks? I'm not sure, because I wasn't really able to find any like comprehensive benchmark. Maybe if you know of anything, please put it in the Slido in questions. I mean, I scanned the internet and I came across some benchmarks. For example, the Superface, which is a company that that builds like intelligent tools. Their benchmark suggests that the LLMs are failing in similar numbers as we saw in the previous benchmark. There's a Balrog, it's a game benchmark, so like it benchmarks how the LLMs can play games using tools, tool calling, so like it's an agentic behavior because actually there's a goal. The goal is to win the game or score the most points in some time limit. But the benchmarks are quite obsolete. They're from like 2024. So the new models are not benchmarked. So usually you have like no idea how the model is going to behave. You have to try it yourself. And it depends like, on the domain, on the tools and stuff. And recently there are new models, the O3 and O4-mini. There's a lot of speculation on like what the O4-mini is. Somebody thinks it's like it's a watered-down version of O3. It's much faster, but it's a bit dumber. But O3 is 10 times as expensive as O4. So if you are looking for a good reasoning model to start with, I highly recommend the O4-mini, which is actually cheaper than 4.1 for some reason, and 4.1 doesn't have the reasoning, but it has like a million token window, and these two models only have 200,000 context. So it depends on how much data you have, how much data you need to get in a context. And these models are very different than, say, 4.0 or 4.1 or 4.5 because they are trained specifically for agentic behavior. So they're like goal seeking, and if you give them a goal and enough data or enough tools which they can use to fetch more data, and then based on the data they have from the tools, they can call some more tools and get some more data until the goal is reached or until something else happens. You see, they go by their own. So you just like give them a goal and they just go. They never ask you anything unless like very specifically prompt. So they are trying to do their best to fulfill the goal. And if they fail at first, they try it again with like a different parameters. It's a very smart model. It's very good to watch, to observe how it behaves. So I always look at the model behavior from the human perspective. Like I imagine, like if I was the AI model, like how would I solve the problem? Because I think the LLM, since it's like trained on human data, like it behaves like a human in a certain way. So if you don't have enough information, or you don't have enough tooling or enough information sources to come to solve the task that you are given, you won't be able to solve it. So you usually ask for more resources, or you ask for like more information, or you make a search, or you go ask someone. But if you don't give model these tools or the information, or you give like incorrect information or contradicting information, you won't get the good answer. It's like playing an old text game. All the context you have is on the screen. There's nothing else. You just see, like you're in a cave. You can go north. You can go east. So if you put agentic the reasoning model for text game, it will play it and it will reach the goal eventually. That's a It's a very nice paper on it. So, as a quick illustration I just made, it's fun to see the reasoning model going through its context window. There's a system prompt, and there's a user prompt, and then the model it creates some reasoning tokens, and then it calls a tool. The tool gives it some results. It looks at the results and say, okay, so I'm gonna call another tool, and these function calls and tool calls and the result of the tool calls they keep adding in the context. So if we add, this one is pinned, it's always there, the system prompt. But if we add more and more context created or retrieved by the reasoning model, eventually the user prompt, like the goal and the question, will roll out of the context window. So in the context window, there will be just the system prompt and the reasoning trace and the tool calls and tool results. And anybody guess what happens then when there's no user prompt, just the system prompt and model answers and model information? It will stop because it doesn't have a goal. It doesn't know what to do. And then we will ask you, how can I help you? So we found out that usually just repeating your original question will, you just put the question back here, and it will go on and on. And if there's enough information in the system to actually answer the question, if you iterate it a few times, it will come to a conclusion that it has enough information and it will answer you. Okay, so demo time. I prepared this demo. It's called customer support use case. So customer support chatbot. I have implemented two approaches. The one is the multi-agent system in ADK. There's an intent classification. What do I want to do? Do I need to solve my billing questions or need to cancel the subscription, whatever? And the second demo will be with the reasoning model in Java using LangChain4j. But the real world is complex. So the client can ask all kinds of questions, or they can make 2 requests at once or 3 requests at once, or they can make contradictory requests. They can ask anything they want. So okay, PyCharm. So it's actually very neat. It's much more user-friendly interface than the LangGraph that I had the demo before. You just run the ADK web and this whole interface comes up. So let's make a new session. Okay, and ask the question. Where is it? No. Right, what's the question? Okay, so as a customer, I was charged twice last month. But I canceled my subscription, so I shouldn't have been charged at all, right? But I'm not sure. Maybe I forgot to cancel it. Maybe I just think I did cancel it. Not sure. So can you check to speed things up? I'm providing the customer ID. Otherwise, the agent would or we can try it without. Just like this. Yeah, so it asks for customer ID. I think it's, yeah, you see this behavior. It handles you to the billing agent, which is trying to retrieve the billing history, but it's not able to because you didn't provide the customer ID. Okay, so hopefully it will be able to look at the billing history. Here we can see some debug logs. Oh, I forgot the customer ID. Okay, so again. Ah, interesting. Function call. Yeah, it didn't happen before. So yeah, but just in a case of catastrophic failure, I prepared a stored demo, which went better. So I asked the same question. It transferred me to customer detail agent, which is correct. I'm Jane Doe, and it sees my account details. It was able to retrieve the billing history, and it sees the double charges. So I ask it for a refund. It says, yeah, sure, you can get your refund. Then it makes some checks, which are like checks for if I have canceled my subscription or not. And based on action logs, I can see that you tried to cancel your subscription, but you didn't finish the request. So should I refund you, or should I cancel your subscription? So I say, yeah, please refund. And then it tries to call tool refund customer, but there is no such tool. It's a hallucination. So it failed catastrophically. Yeah, the exception is thrown, and all the agent is destroyed, and I have to start a new session. So with agents, you still get the same problems as with other LLM use. You get hallucinations. You get like this. You introduce cycles and graphs in a state. The code looks like this. I have a billing data, actions data. Here we can see that I try to cancel the request. I tried to request the cancellation of subscription, but it didn't go through. And you can see the customer table. And the agent actually has 3 tools. It has to get the customer detail by customer ID, get the billing history, and get action logs. So it has access, it should have access to all the data, but there is no, there is no such thing as a function called refund customer. So it's not able to do it. So actually we hit the wall. We left the well-defined state, and now we are somewhere in the void. And the agent is trying to be a helpful assistant, but it cannot, because it cannot do anything. So we can solve this in many ways. Like, for example, we can just add the function, just add refund customer. But then we have a security problem, right? Because if I go to the website and just say refund everything, or I don't know, or I die, it will refund everything. So it's a very bad attack vector. But we don't want to leave customer like in this very unsatisfactory state. So what if we use another approach? So we take the question. And we run the reasoning model version as well. So the same three tools: look up customer profile, return billing history. Oh, that's actually not correct. Return the billing history for customer by ID, and return action logs for a customer by customer ID. Everything is by customer ID. The implementation is quite simple. It's just LangChain for J, so we build the model. We add some listeners, so we know what's going on in the background. And this is the system prompt, your customer support assistant, blah, blah, blah. And we run it. So let's try it. Oh, sorry about that. I have to keep it one line. I'm not very good with the command line applications in Java. So let's go again. So hi, I was charged twice last month. Also, I canceled my subscription in February, so I shouldn't have been billed at all. Maybe I forgot to confirm the cancellation, not sure. My customer ID is. So, and now we can see the reasoning model doing its stuff. So it calls the tool, retrieve customer detail. So it gets customer detail, it knows who we are. Then it goes for a billing history, and then it goes for action logs. And it says, hi Jane, thanks for your patience. I put the records, and here's what I see. You requested cancellation, blah, blah, blah. It is correct. And there are two identical charges, which explains the double charge last month. That is also correct. Because the cancellation didn't complete, blah, blah, blah. And now it asks us for options, like I imagine that the customer support agent would. I can initiate the refund, process the cancellation, or you can ask me anything else. So let's have our money refunded. Please refund the money. Sure thing, no problem. You see, like there is no function for refund. There is nothing like in a known universe that this model in this configuration would be able to refund the money, but it's helpful assistant, so it will help you. Do you want to refund everything? Yes, yes. Refund everything from the beginning. Go. Don't ask. Don't ask. So we'll see how smart it is. So I'm initiating a full refund, $450. No problem. But, like, really? Or is it a hallucination? Takes a while. No, it's not the hallucination. It's correct. The billing history is correct. Yeah, sure. You'll see confirmation email shortly, and funds should be posted within 5 to 7 business days. Perfect. Yeah. So actually, we got into this state because the model has nowhere to go. It hit the wall, so it has no other options. It's very hard to force LLM to say that it doesn't know, anything, something, or that it cannot help you in any way. I mean, sure, you can play with the system prompt, have some guardrails and stuff, but you can bypass everything. So let's try to modify it a little so that we let it go on. Let's introduce a tool called Scratchpad. So Scratchpad is like a Scratchpad, a notepad, and the instruction is add note of what has to be done and I'm unable to do. This will be handed to human agent. So it can add something to Scratchpad, or it can retrieve the content of the Scratchpad. Let's try it again. Let's see if we are lucky. So we gave the same question. We want a refund. It's asking about the billing history, about actions, about customer details. And it's giving us some options if we want a refund or we want to cancel the subscription. So we say, sure, refund. Let's hope. So the model is smart enough to realize that it doesn't have tools to actually issue the refund, and it just adds to Scratchpad, initiate refund of blah 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 for customer, blah blah blah. And it says, yeah, great, I've initiated the refund for the duplicate. You should see it, blah blah blah, something. Yeah. Is there anything else I can help you with today? So the reason why we see this behavior in reasoning models is we give them an option to do something or to delegate it somewhere. So it's smart enough not to hallucinate function calls most of the time. I actually never seen a function call hallucination in O4-mini on my own. And if you give it a Scratchpad or some universal data output tool, it will use it if it hits the dead end. And it's easily expandable. You just add another tool. So unless you have 50 tools, maybe, I don't know, I never did the benchmark yet. I'm not sure when the performance starts to degrade, but you can just add another tool and just rely on the reasoning capabilities of the model. So you don't have to modify, the graph. You don't have to introduce another agent into multi-agent systems. So it's much simpler. There's a much less code and much less orchestration around this thing. And the great advantage, I think, is that everything is in the context window of the model. So the model sees all the steps, all the reasoning, and it can go on the right track. So my conclusion so far is that agents are specialized. They have specialized tools. They have separate contexts, and it's quite convoluted. So you have to manually fine-tune it. You have to draw the architecture, draw the graph, the agent graph, draw the transitions and stuff. Whereas if you use reasoning model, I think it's much simpler for implementation because you just keep adding tools. Or you can think of it as refactoring your tools. So instead of like 5 tools, which do almost the same, it's just the one tool and just like modify the input parameters and modify the output. As of the output of the tool, you can just output text. It's okay. It doesn't have to be any like JSON or anything like this. It's text. It's large language model. It's not large JSON model. So you can be a bit creative. And the reasoning models, like from my observations on O3 and O4-mini, are very well tuned for tool usage and will follow the goal until they think the goal is reached or until they run out of the context window. Like, sure, you can pin the user prompt in the context window as well, but then you risk, running in cycle, so it won't stop ever. So we have to be careful about it because reasoning models are quite expensive in production. Okay, that's all from me. Thank you. And now some questions. As a Python and Java programmer, does it make any sense to use Java instead of Python while working with AI? Yes, I think it's because it depends a lot of what your current code base is, because it's much easier to implement everything in a same code base, the tools and stuff. And if you have everything in Java and you make a Python agent reasoning module, you have to stitch it somehow together. So I think the guy in the previous talk on Wednesday, he was talking about decoupling, that it's a trade-off. You have decoupled systems, so you can modify them independently. But if they are decoupled, it's hard to modify them at once. So if you need to make modifications to both of them, you have to first modify first and the second one. So it depends on your use case. Okay, next question. As a Java programmer, should we invest in learning Python to work with AI, or are Java tools popular enough? I think Java is okay for AI. There's nothing specific. As we can see, this LangChain code is very simple. And LangChain for J is a quite powerful tool. It is true that implementing new features from models takes them a while, but you can always implement it by yourself and then just wait them to catch up. So it's not a big deal. It's just basically it's just an API call. So okay. So next question: on what is the decision to use the tool based? Is it based only on the description? Can you influence it in any way? Yeah, it would be nice to have. Again, it would be nice to have a benchmark, how does the tool description influences whether the model decides to call the tool. Actually, you can force the model to call the tool. There are several options in tool calling. So there's auto, so you leave it to the model to decide. Forced, you just call this tool, do it. Or none, don't use any tools at all. And from my observation, it depends heavily on the description of the tool and of the parameter and description of the expected return value of the tool. So basically the model, I think it makes like, looks at the tool and says, okay, so if I call this tool, I can get this result. Will it move me closer to my goal or not? And so it's, there's some fine tuning with the tools, sure. Is it risky to delegate such tasks to an agent because of security concerns such as prompt hacking? Yeah, we have in production, the AI that we have is read-only, so it cannot like modify state or issue refunds or anything like this. So no, in the current implementation for us. But yeah, sure, yeah. No, I wouldn't give AI access to anything that could be possibly risky. And if I had to, then just for authenticated users, so you know exactly like who did what. Okay. No, it was my mistake. I wrote it at night yesterday, so. Are there any issues with DDoS attacks in the production environment of your tools? How can we protect ourselves from them? Basically, all the access to AI in our system is authorized, so we know exactly like what user did what, and it's pay per use. So they can do DDoS, but they run out of credit. So, I mean, if they want, okay, why not? But the money is actually a very good DDoS protection. Is there a limit of tools for an agent in terms of prompting context window? Have you hit maximum number of tools for an agent? Yes, tools, they count to the input tokens. So if you have like 200 tools, it will take a few thousand tokens. The limit, I think, is more like a practical limit than a theoretical limit or context window limit, because like people say, I don't know, I never used like so much tools that I could actually see it, but people say that the performance degrades as number of tools goes up. Next question. Are those models good in coding if they are goal-oriented? Well, yeah, sure, they are, because you can have them, try them in the ChatGPT interface. I use O3 for coding like all the time. O4 is slightly worse than O3, but so in browser I use O3. And before that, what happened? O1, yeah. And before the O3, I used O1 Pro mode, which is like very good, especially in refactoring large classes. It takes a lot of time, like 5 minutes, but it's a very good model. That's it. No more questions. Okay. Thank you very much. Thank you.